Hello everyone. Today we'll be discussing about integers, powers, roots, and numbers. This topic is taught to Form 1 students who are taking checkpoint kind of syllabus. Uh, for those who are very new to checkpoint syllabus, checkpoint syllabus is uh, the kind of curriculum that is offered by Cambridge, and normally it is taken by students who are in year 7, year 8, and later year 9. And once students reach year 9, they usually sit for their checkpoint exam, which is usually done in the month of April every single year. And currently we have Form 2, or we have year 9 class running, and we are expecting them to sit for their checkpoint exams next year, inshallah, in April. So without wasting your time, now let us discuss integers, powers, roots, and numbers to our students who are in year 7 and as well as in year 8. Right, so we have a worksheet here. Let us start with the first topic, or the first concept, and this is arithmetic with integers. Now, arithmetic with integers, this involves addition of integers, subtraction of integers, multiplication of integers, as well as division. Now we have the first question here, which says, here is a subtraction table. Two answers have already been filled in. The concept is, when you take the first number here on my left hand side, and the second number on the right hand side, when you take the first number minus the second number, then you get your answer. For example, we have this number here. This is the first number, which is 4, and the second number, which is negative 4. So when you do 4, which is the first number, minus the second number, which is negative 4, over here, what do you expect? So this is what we call subtraction of integers. So you see that we have negative followed by another negative sign. So you have to take this negative times this negative. That will make positive. So this will be 4 plus 4, and the answer is 8. So you can see 8 has been recorded underneath negative 4. And also you can see this is done as the second example. Negative 4 is your first number, so you put it over here, minus the second number, which is 2. So every single number here is negative. That means even the answer will be negative. But now negative how much? You take these two numbers, you add them. So it is 4 plus 2. This equals negative 4 plus 2 is 6. So the answer will be negative 6, as how it appears over here. Now let us try to do some few questions or some few subtractions of integers from here. Let us say I'm looking for the number which I should fill over there. So what I do, I take the first number, which is 4, minus the second number, which is negative 2. So it will be 4 minus negative 2. And then I do 4 negative times negative is positive. And here the answer becomes 4 plus 2. This equals 6. So the answer that you fill up here is 6. Okay, how about the number you fill in here? It's simple. You just do 4 minus 0, it's 4, and then here you do 4 minus 2. 4 minus 2 is 2. 4 minus 4 is 0. 2 minus negative 4, you get the number to fill over here. So 2 minus negative 4, like as I said earlier, this will be 2 plus 4, and the answer is 6. So 2 minus negative 4, we got 6. 2 minus negative 2, the answer will be 4. How? This is 2 minus negative 2. So 2 minus negative 2, this becomes positive. So 2 plus 2 is 4. So you fill up over here. This is 4. And when you do 2 minus 0 is 2. 2 minus 2 is 0. 2 minus 4. Oh, 2 minus 4. This is a small number, this is a bigger number. When you have the smaller number minus this, when you have got the smaller number minus the bigger number, the answer is negative. So negative how much? 2 minus 4 is 2. So 2 minus 4 is negative 2. And 2 minus 4, you write here negative 2. 0 minus negative 4. Okay. Let me delete everything over here. Okay, so we have, let me remove everything over here so that we can get a space for us to write. And yes, there we go. We have 0 minus negative 4. Okay, so 0 minus negative 4, this becomes positive. 0 plus 4, the answer is 4. Right here, 4. 0 minus negative 2, the answer will be 2. 0 minus 0, the answer is 0. 0 minus 2, 0 minus 2, cancel that, means with the negative 2. So 0 minus 2 is negative 2, and 0 minus 4, same thing, it will be negative 4. Negative 2 minus negative 4. Negative 2 minus negative 4. This becomes positive, so it will be negative 2 plus 4. Now, here you must be very careful. You have a negative number followed by a positive number. So what we basically do, we switch the numbers around. So the positive 4 starts over here, followed by the negative 2. So you switch the numbers like this. Exchange their positions. This is negative 2 plus 4. When you exchange their positions, it becomes 4 minus 2. And 4 minus 2 is 2. Okay? So when you do negative 2 minus negative 4, the answer is 2. Negative 2 minus negative 2, let's do that. Negative 2 minus negative 2, this becomes positive. Negative 2 plus 2, switch the numbers around, exchange their positions. This becomes 2 minus 2, and the answer is 0. So negative 2 minus negative 2, we got the answer is 0. Negative 2 minus 0, negative 2 minus 0, this will be negative 2. Negative 2 minus 2, negative 2 minus 2, here will be the working. Negative 2 minus 2, every single number here is negative, so even the answer will be negative. But then negative, how much you have to add these two numbers? This is 2 plus 2. 2 plus 2 is 4. But do we have a negative sign over here? So the overall answer will be negative 4. So in that case, negative 2 minus 2, the answer we got negative 4. Same applies here. Negative 2 minus 4, the answer will be negative 6. Negative 4 minus negative 4, the answer will be 0. As we discussed earlier, negative 4 minus negative 2, the answer will be negative 2. Let me show that. Negative 4 minus negative 2. We have negative 4 minus negative 2. This becomes positive. Negative 4 plus 2. You need to switch their positions, and this becomes, we have 2 starts over here, followed by negative 4. So 2 minus 4, the answer will be negative 2. Like as I said earlier, when you have got the small number minus the big number, the answer will be negative. Right, so that will be negative 2. Okay, where are we? We're over here. Negative 4 minus negative 2. We got negative 2. Negative 4 minus 0. Negative 4 minus 0. Cancel that, so you have negative 4. Okay, negative 4, you put it there. And negative 4 minus 2, we did that. We got negative 6. Negative 4 minus 4, let's see the working. Negative 4 minus 4. Negative 4 minus 4, we have, this discussion was done earlier. Every number here is negative. So even the answer will be negative, but negative how much? You do 4 plus 4. And 4 plus 4 is 8, so the answer will be negative 8. And if the answer you fill up over here, negative 8. As simple as that. Then let us go to next page of the worksheet. We have this question here. The instruction of the question says each number is the product of the two in the row below it. Fill in the missing numbers. Okay, fill in the missing numbers. The instruction is the product of the two numbers in the row below it. So that means to get this number over here, you do the missing number times negative 16, the answer is 64. Or somebody who is very good in algebra, the number which you are missing will be treated as a letter. Call it y, for example. So y times negative 16, the answer should be 64. In other words, to find the missing number, you will take this number up here, which is 64, divide by the number below it. So you do the reverse. Divide by negative 16. That is how you get the missing number over here. The idea is each number you see is the product of the two in the row below it. That's the instruction. That means you're looking for this number, for example, 64. So the idea is take these two numbers which are below 64, multiply them. Those two numbers, when you multiply them, you get 64. That's the idea. Now, if one of the two numbers missing, so what we do, you take 64 divided by negative 16, you'll get the missing number over here. That is a cool idea. It's a cool idea. So let us see what is 16 divided by negative 16. 64 divided by negative 16, you get the missing number will be This is positive. Positive divided by negative, the answer is negative. 64 divided by 16, the answer is 4. So the missing number over here is negative 4. Or you can pull out your calculator. You can pull out your calculator and do the calculations. We have 64 divided by negative 16. So you do 64 divided by negative 16. The answer will be negative 4. So we are correct. Good. We have two numbers missing over here. One is to be found over there, and another number's somewhere here. The same concept that this number here, which is 2, times the missing number, the answer should be equal to negative 16. Cool idea. So 2 times a missing number, the answer should be negative 16. In other words, to get the missing number, you do negative 16 divided by 2. You just do the opposite of multiplication, which will be negative 16 divided by 2. Now, like as we said earlier, you start with signs. Negative divided by positive, the answer is negative. 16 divided by 2, the answer is 8. So here we go. This number missing over here is negative 8. Likewise, we have this number missing over here times 2, the answer will be negative 4. The missing number times 2, the answer is negative 4. So the missing number will be equal to negative 4. Divide, you do the opposite of multiplication, that is division. So negative 4 divided by 2 will give you a missing number. So negative 4 divided by positive 2, the answer is negative. How? Negative divided by positive, the answer is negative. And 4 divided by 2 is 2. Correct. So the missing number over here will be negative 2. End of the question. Then we head to the next question, which says write down the missing numbers. Write down the missing numbers. Same method applies over here. Just consider the missing number as a letter, for example, call it y. So this will be 4 times y equals to negative 20. Right, before that, let us try to set margins so that the solution of part A will end there. The solution for part B will be done over there. And the solution for part D will be done in the last area. Okay, so like we discussed, there are 2 ways you can do that. This question, 4 times a letter equals to negative 20. So what is the missing number? So you do the reverse of multiplication. This will be the missing number will be equal to negative 20. The opposite of multiplication is division. So negative 20 divided by positive 4, you get the missing number. And this is negative divided by positive. The answer is negative. Negative divided by positive is negative. 20 divided by 4 is 5. So the missing number over here is negative 5. So you write here negative 5. Correct. Oh, wow. Now you get this question. You must be very, very careful because this is division. So I will go for the use of algebra. Keep the missing number as a letter y. So this will be y divided by negative 2. The answer is negative 6. Okay, so I will go for the use of fraction when it is division. So this will be y divided by negative 2. The answer is negative 6. Okay, since this is a fraction on my left hand side, I also consider this is a fraction, and hence I do cross multiplication. So y times 1 is y, and then I do -2 times -6. -2 times -6, I've got y. The missing number will be negative divided by negative. Sorry, negative times negative, you get positive. And 2 times 6, the answer is 12. So what does it mean? It means that the missing number over here is positive 12. So you fill up positive 12, but it's not that much necessary that you must write positive 12. You can just write 12 like so. So let us do part C. Part C is a certain number over here minus -5. The answer is -2. Correct. So consider the missing number as a letter, call it x, minus -5, that equals to -2. Okay, like we discussed earlier, negative times negative, all this becomes positive. So this will be x plus 5 equals to -2. Now to find the value of x, what we do, we shift that positive 5 over here, and remember to change its signs as it shifts from one side to the other. So this will be x equals to -2. This is positive 5. When it goes on the right hand side, it will be -5. So what did we discuss earlier? We said that every number you see here is negative, so even the answer will be negative. So negative how much? You have to add 2 and 5. So when you add 2 and 5, the answer will be negative. 2 plus 5 is 7, so the answer will be -7. In that case, the missing number over here will be -7. So that is the answer. Right. Just come to part D. We have a missing number over here times -3. The answer is 12. So in other words, you do the reverse of multiplication, that is division. So this will be 12 divided by -3 straight away. So the missing number will be equal to, this is positive divided by negative, you get negative, and 12 divided by 3, that is 4. So over here, the missing number will be -4. Okay. -4, cool, yeah? Right. So we go to the next question. Let us try to put margins over here so that we can have regions for solution for part E. Later we're going to have solution for part F. Consider the missing number as a letter, call it, for example, M. So the whole idea will be -2 plus the missing number. I'm treating the missing number as a letter. So -2 plus m equals 2. To find the value of m, we need to transfer -2 from the left hand side and come over here, just leaving m exposed like so. This will be 2. Now this is -2. When it shifts over there, it will be +2. So in that case, the missing number m will be 2 plus 2, and that is 4. So the missing number over here is +4. Cool, yeah? Okay. Let's go to F. Consider the missing number as a letter, call it, say, W. Any letter you're comfortable with, you can use that. So this will be W minus 4 equals to -3. So I'm looking for how much W is. So -4 will be transferred on the other side, leaving W exposed like so. This will be -3 plus 4. Why? Because this is negative. As it moves on the other side, it becomes positive. So this will be The missing number, which is W, will be negative 3 plus 4. Now here you should be very careful. Some students make some small errors. To just cut off those errors, we simply switch the numbers around like so. That becomes 4. That remains negative 3. So the answer becomes 4 minus 3. This is positive 1. So the missing number over here is 1. Cool, yeah? Good. Let's go to next page. Sorry, I'm moving so fast because I believe that you have some ideas with regards to year 7, year 8, and year 9 kind of maths. Okay. Find, we have this page which is talking, this page will be talking about multiples, factors, and primes. Primes means prime numbers. Okay. So the question over here is find the factors of each number. Wow, we have how many numbers? We have 1, 2, 3, 4, 5, 6. Okay, we have 6 of them. We want to find the factors of each single number over here. But now you should remember, what does a factor mean? We say a factor, a number is said to be a factor if it is divisible by that number. And the smallest factor of every single number is 1. So every single number, the smallest factor of every single number is 1. So we start with 1 as the factor of every single number. Now, how do we get the next? The next number, you take 20 divided by 1. So 20 divided by 1, any number divided by 1 equals that number. So 20 divided by 1 will give you another factor, that is 20. All right, the next number after 1 is 2. Then you check if 2 is divisible by 20. Now 20 divided by 2, yes, 20 divided by 2, so we say 20 is divisible by 2. So 2 is a factor of 20. Now let us see what is 20 divided by 2. 20 divided by 2 is 10. So 10 will be another factor. Go to 3. 20 divided by 3 is not divisible. So 3 is not a factor of 20. Okay, go to 4. Yes, 20 divided by 4 is possible. So 20 is divisible by 4. Now, how much is the answer? You do 20 divided by 4. The answer is 5. Okay. Go to 5. 5 is already recorded over here. Go to 6. No. Go to 7. 20 is not divisible by 7. Go to 8. No. Go to 9. 9. No. 20 divided by 9 is not possible. Go to 10. 10 is already recorded over here. Go to 12. Go to 11 is not possible. So these remains to be our factors. These remains to be our factors of 20. So we can say the first factor of 20 is 1, 2, 4, 5, 10, and then 20 itself. All right, let us see the factors of 27. Okay, the factors of 27, like as I said earlier, when you are told to mention the factors of any number, start with 1, because 1 is a factor of every single number. Okay, 27 divided by 1 is 27 itself, and then move to 2. 27 is not divisible by 2. Go to 3. Yep. 27 is divisible by 3. Now, 27 divided by 3, the answer is 27 divided by 3, the answer is 9. So 9 will be one of the factors of 27. Go to 4. 27 is not divisible by 4. Go to 5. 27 divided by 5 is not possible. Keep going. Try 6. No. Go to 7. 27 divided by 7 is not possible. 27 divided by 8 is impossible. Go to 9. 9 is already here. Go to 10. Okay, so the only factors which we can just draw out quickly, the factors of 27 are 1, 3, 9, and 27. So the first factor is 1, second is 3, another factor is 9, and then 27 itself. Those are the factors. All right, the factors of 75, call the 75 is divisible by 1. Okay, so 1 is a factor of every single number. So 75 divided by 1, we record the answer over here. Then you go to 2, 75 is not divisible by 2. Go to 3, 75 divided by 3 is, this is, you do this 2 times 3 is 6. Do that, that will be 15. 15 divided by 3, the answer is 5. 5 times 3 is 15. And the remainder is 0. So in other words, 75 is divisible by 3, and the answer, 75 divided by 3, the answer is 25. Or you can pull out the calculator, especially those who are doing IGCSE. They all use the calculator all the time. Okay, 75 divided by 3, so pull up your calculator. You do that, 75 divided by 3. Then you enjoy, the answer is 25. Then after 3 goes to 4. 75 divided by 4 is not possible. Go to 5. Yes. 75 divided by 5. The answer will be 15. Or pull out your calculator to save time and do some kind of accuracy. 75 divided by 5, the answer is 15. Go to 6 is not possible. Go to 7 is not possible. 8, 9, 75 divided by 9 is not possible. Go to 10. 75 is not divisible by 10. Then I think these are the only factors of 75. Yeah, these are only factors. So quickly you write the first factor is 1, go to next is 3, 5, 15, 25, 75. These are the factors of the number 75. How about 23? 23, yes, the smallest possible factor of every single number is 1. So you start with 1, then you just continue. So 23 divided by 1, the answer is 23. 2, 23 is not divisible by 2. Try 3, no. Try something as 4 is not possible. 5, 23 is not divisible by 5. Yep. So we can see that 23 is having only 2 factors. Wow. This is 1, 23. So we have only 2 factors of 23. Now, what does it imply? Later I'll be talking about prime numbers, or I'll be talking about primes. A number which has got only 2 factors, I should repeat that. A number which has only 2 factors, and that is 1 and itself, such number is known as a prime number. So 23 is a prime number. Why? Because it has only 2 factors, and these are 1 and itself. So a prime number is any number except 1 which is divisible by 1, and also it should be divisible by itself. Okay, let's go to factors of 100. Okay, like as we discussed earlier, the smallest possible factor of every single number is 1. To get the next factor, you do 100 divided by 1. That will be any number divided by 1 equals that number. Then you go to 2. Yes, 100 divided by 2, that is 50. And then you try 3. 3 is not possible. You try 4. Yes, 100 divided by 4, that is 25. Or to be sure, you can pull out your calculator for the IGCSE students and do 100 divided by 4, you get 25. So you take use of a calculator if we have got one on our table, and do 100 divided by 4, that is 25. Try 5 over here. 100 divided by 5, yes, it's possible. 100 divided by 5, the answer is 20. Okay, cool, yeah. Let me find a space for like some few factors. I can see some few of them. Okay, let me do that. Shift these numbers over here, pull a little bit down so that we get enough space over there for us to fill on some few more factors of 100. Right, here we go. We tried 5, we got 100 divided by 5 is 20. Try 6, no, because 100 divided by 6 gives you a decimal, so 6 is not a factor of 100. Okay, like so. You try 7, nope, because 100 divided by 7 is not possible. It's giving you the decimal. What is that? That signifies that 7 is not a factor of 100. Try 7, 8, 9, 10. Try 10 over here. 100 divided by 10. 100 divided by 10 is 10 itself. So we don't have to record the number twice. Okay. Can we go to 11? Nope. Go to 12, 13. Nope. Yeah. I think this will mark the end of the factors of 100. And you can list them all over here. You can list them like so: 1, 2, comma 4, 5, 10, 20, 25, then 50, and lastly we finish with the number itself. Cool, yeah? Good. Factors of 98, start recording 1, because 1 is the smallest possible factor of every single number. To get the next other number, you do 98 divided by 1, so the answer is 98. So 1 is a factor of 98, and also 98 is a factor of itself. Okay, 98 is an even number, so 98 is divisible by 2. Now we do some calculations. 98 divided by 2, the answer will be 49. So you record it over here. 98 divided by 2, the answer is 49. That is correct. Then you go to 3. 98 divided by 3 is not possible. You try 4. Just pull out your calculator. Yep. Take out your calculator and do the calculations. Like so. That will be 98 divided by 4. You get a decimal, so 4 is not a factor of 98. Try. After 4 comes 5, no, 6. Try 6 over there. Let us see if 98 is divisible by 98 divided by, okay, let us see, 98 divided by 6. Nope, you still get a decimal. So quickly, 98 divided by 7, and then divided by 7, that will be 728. Yes, this is possible. 98 divided by 7, the answer will be 14. Yep, 98 divided by 7, the answer is 14. So 14 will be also the factor of 98. Try 8. Nope. Then, yeah, I think these are the only factors of 98. Try 8, not possible. Try 9, 9 is not possible. Yep. So all these are the factors of 98. You can try to figure out some more if you can, but I think these are the only ones. So 1, 2, 7, 14, 49, and then the 98 itself will be one of the factors. Okay, having obtained all the factors of each number over here, let us go to find the first 4 multiples. Okay, multiples of each number. Okay, what is a multiple? A multiple of a number, first of all, the word multiple comes from the concept of multiplication. So if you are looking for the first multiple, for example, of the number 18, because the concept of multiples comes from the concept of multiplication. So if I'm looking for the first multiple, okay, first multiple of 8, so I take 1 multiplied by 8, I get 8. So the first multiple of 8 is the number itself, right? Now, when I'm looking for the second multiple, of 8, I'll take 2 multiplied by 8, and that gives me 16. So 16 is the second multiple of 8. So, and so on and so on. So if I'm looking for the third multiple, I will do, my third multiple will be equal to 3 times 8, the third multiple of 8, this will be 24. Okay, then I carry on, I go on with the same concept, and that will give me the fourth multiple. So this is the fourth multiple. I do 4 times 8, and that will give me 32. Okay, now what are the multiples in that case? So we got over here the first multiple was equal to 8, second multiple was 16, the third multiple is 24, the other one, which is the fourth multiple, is 32. Correct. Now there is another way of finding multiples of a number. For example, but I'm going to use only the concept of multiplication. For example, so let us see another alternative. So alternatively, we have an alternative to this method. The question here is find the first 4 multiples of each number. Okay, now let us start with the first number. This is 8. So if you're looking for the multiples of 8, you start with 8 itself. Okay, you start with the number itself. This is 8, and then to get the next number, to get the next multiple of 8, what you do, you add the number itself over here. So what is 8 plus 8? That gives you 16, which is the next multiple of 8. Okay, to get the next multiple, what you do, you take this number here, which is 16, again add the number itself. So what is 16 plus 8? This will give you 24. And 24 will be the third multiple of 8. Now to get the fourth multiple of 8, you take this number, which is 24, add the number itself. What do you get? 24 plus 8. The next number will be 32. And so on and so on. If you're looking for the fifth multiple of 8, what you do will be very easy. You simply do from where you ended with the fourth multiple. So from here, you again add 8 32 plus 8, you get 40. Now, since the question is asking for the first 4 multiples of 8, you will be stopping over there. Okay, so here we stop. Okay, so I'll be mixing. Maybe let me try to mix the methods. I don't know if you'll be confused, but I'm not sure. Let me start with the concept of multiplication. So if you are looking for the multiples of any number and you want to move with the concept of multiplication, this will be your method. So if I'm looking for the first multiple of 15, what I do, I take 1 times 15, I get 15. So the first multiple of 15 is the number itself. The second multiple, I take 2 times 15, that gives you 30. You see that? Cool, yeah? Good. All right. Now, to get the third multiple of the number 15, to get the third multiple, you do 3 times 15, that gives you 45. To get the fourth multiple of 15, you just do 4 times 15, that gives you 4 times 15, that gives you 60. Now, what are these first 4 multiples? We got 15 is our first multiple, we got 30 is our second multiple, we got 45 is our third multiple, the last multiple will be 60. Cool, yeah? Okay. Now suppose I don't want to use the concept of multiplication. Probably, maybe I'm not good in multiplication, so I want to use the concept of addition to find the multiples of the number 15. Okay, alternatively you can do as follows. The question is to find the first 4 multiples of 15. So you start with the number itself, and that is 15. Now to get the next multiple, we add the number itself. So 15 plus 15, you get 30. To find the next multiple, you add the number itself, which is 15. 30 plus 15, you get 45. To get the next multiple, after 45, you take 45, add 15, you will get 60. To get the next multiple, add 15 to 60, that will take you to 75. To get the next multiple, after 75, add the number itself, that is 15. That will take you to 75 plus 15, that will give you something 90. Now, the question is asking for the first 4 multiples. So the first, the second, third, fourth. So these will be deleted. Okay, now how do we record the answers? The answers, we put them in the listing format. Here we got 60. So let us get a list of the first 4 multiples of 15. The number we got is 15 as the first multiple, and then we went to 30, we got 45, we got 60. Cool, yeah? Good. So let me write this number properly. Write that. Okay, this is 15, 30, and this is 45. Correct. Good. I don't know if you can pause the video and try the next few numbers over here, 7, 20, 33, 100, and after pausing the video, try the remaining other numbers, and then try to check if your answers will match with my answers. My answers are as follows. Okay, the first multiple is 7. Add 7 to this number here. So the first multiple of a number is a number itself. So when you take 7, add 7, what do you get? You get 14. You get the next multiple, add 7 over here. What do you get? You get 21. get the next multiple, add 7 over here, you get 28. To get the next multiple, you also add 7 here, and that will take you to 35. See that? But because the question needs the first 4 multiples of 7, this is 1, 2, 3, 4. So 35 is not supposed to be in the list. Why? Because they are saying, question says find the first 4 multiples. So let us get a list of them. The first multiples, one of the multiples of 7 is 7 itself, and then we got 14, then we got 21, and then we got 28. And this is using the concept of addition. Right, let me do the next number. Let me work out the multiples of 20 by using the concept of addition, and then I will do E and F using the concept of multiplication. Okay, using the concept of addition, multiples of 20 are, you start with the 20 itself, and then to get the next number, you need to add 20 to the previous number. So 20 plus 20, that makes 40. To get the next multiple of 20, you add 20 to the previous number, that was 40. So 40 plus 20 is 60. To get the next multiple after 60, what we do, you take 60, add 20, you get 8. See that? Let me do that right clearly. That is 80. Correct. Now, because they need only 4 multiples of the first 4 multiples of 20, let us get a list of them. The first multiple is 20. The second multiple is 40. The next one after 40 comes to be 60, and the next one is 80. Yeah. So these are the first multiple. The first 4 multiples of the number 20. Now let me use the concept of multiplication to get all this work done. Okay, so the first multiple is the first multiple of the number 33. You do 1 times 33, you get 33. The second multiple of the number 33, you take 2 times 33. That will be 6. To get the third multiple of 33, you take 3 times the number itself. The number we have here is 33, so do 3 times 33. This will be 9. Then to get the fourth multiple of 33, you do 4 times 33. This will be 12. That will be 12 carry 1. So 12 add 1, that will be 132. Good. Now, the multiples of the number, the first multiples of the number 33 will be listed below here. The first multiple is 33. The second multiple is 66. Third multiple is 9. Okay. And the fourth multiple is 132. You can pause the video still and try the last number, which is 100. Without wasting time, let me use the concept of multiplication to find the multiples of 100. The first 4 multiples of 100. This will be the first multiple of 100. Just take 1 multiplied by 100. This gives you 100. To get the second multiple of 100, you do 2 times 100, and this gives you 200. To get the third multiple, do 3 times 100. This will take you to 300. And then you do 4 times 100 for the fourth multiple of 100. 4 times 100 will give you 400. So what are the first 4 multiples of 100? Okay, the first multiple of 100 is the number itself, 100. Next is 200. Next is 300, and the fourth multiple of 100 will be equal to 400. Cool, yeah? Good. So now let us see. We do not have the next question on this page. So let us put the margins clear. These are the margins which separate the solutions of every single question over here. So on this page, I don't see the next question. Let us do to the next page. And this is the page. It has how many questions? It has some questions. Okay, the question starts as follows. Good. The 17th multiple of 8 is 136. The 17th, okay, here the 17th multiple of 8 is 136. We can check that if it is correct. Check. 17th multiple of 8, that means the position number they are talking about is 17. So the 17th multiple of 8, that means take 17 times 8. And this gives you can pull out your calculator and do some calculations over here. Correct. So do 17 times 8 to check that. See that? Giving you 136. So this information is correct. Now let us see the questions. Okay, the questions are as follows. Putting the margins to separate the two solutions. What is the 18th multiple of 8? Okay, two ways you can do that. We have the 17th multiple already of 8 is 136. So how can we take advantage of this? What we do, the 17th multiple is here, 136, and we are looking for the 18th multiple of the number 8, of the same number. So what we do, in counting, when you are counting, when you reach 17, the next count is 18, definitely. So if this is your 17th multiple and you are looking for the 18th multiple, what we do, since this is the 17th multiple and you are looking for the next multiple after 17th position, what you do, because they are talking about the 17th multiple of 8, what you do, you add 8 over here and see the answer we get. 136 plus 8, this will be 14, carry 1, this is 144. So the 18th multiple of the number 8 will be 144. Right? Now this is using the concept of addition. Now, using concept of multiplication, alternatively, the question is talking about to work out the 18th multiple of 8. So what we do, because we are looking for the 18th multiple of the number 8, what we do, you take the position number that is 18, multiplied by the number itself, that is 8. So 18 times 8, pull out your calculator and check if it will match exactly with our first answer. So 18 times 8, see that? We're getting 144. So 144, that is your 18th multiple of 8. Cool, yeah? So we have two methods, not definitely two methods, but these are two quick methods we can use to find multiples of a number. So you choose which method is convenient to you, and then you go for it. Cool, yeah? Good. Now here is, we'll go back to the previous question. The question says the 17th multiple of 8 is 136. The question is, what is the 16th multiple of 8? Okay, so we have the 17th. We have the 17th position. We have the 17th position. And then we are looking for 16th position. Okay? Now here is like working on the reverse. You see? We are trying to reverse the process. Right? Now, the 17th multiple of 8 is 136. Oh, yeah? Then we are looking for the 16th multiple. 16th multiple of 8. So now, since we are looking for the position number before 17th position, so we need to subtract 8 from here. Subtract 8 from this number. What do we get? 136 minus 8. 16 minus 8, that is 8. Here we remain with 2, so 12 minus, minus 0, you get 128. Okay? So you can pull out your calculator. For those students who use calculators in the examinations, you can pull out the calculator and do 136 minus 8. Then you do 128. So 128 will be the 16th multiple of 8. Alternatively, we can use the concept of multiplication. Okay, how do we do that? So this is second alternative. So alternatively, okay, we have we don't have to take reference to this. We don't have to take reference to this. We just work out by using the concept of multiplication. Okay. Now the question is, how do we do that? The question is, what is the 16th multiple of 8? So the position number is 16, and the number they are talking about is 8. So you do 16 times 8, pull out your calculator, work out 16 times 8, you'll get the same result. So 16 times 8 is 48, and when you do 1 times 8, you get 8 adds 4. This is 128. Or you can pull out your calculator and straight do 16 times 8. That is 128. All right, maybe to clarify the what checkpoint is all about. Usually when the students of year 7, year 8, and year 9, when they finish up their course of 3 years, normally, like as I said in my introduction earlier, these students of year 7, year 8, and year 9 are going to sit for their checkpoint exam. And this checkpoint exam, especially of maths, has 3 papers. We have paper 1, we have paper 2, and we have paper 3. Now, paper 1, students are not allowed. I repeat here. For paper 1, for the examination, checkpoint exam, paper 1, students are not allowed to use their calculators in their examination room. But when it comes to paper 2, students are free to use their calculators. Paper 3 is mental kind of exam. You use is some sort of dictations, okay, and the students are supposed to use their mental ability to figure out the answers very quickly. And actually, for the first batch of our previous students, they just set for 2 papers, paper 1 and paper 2. They didn't do paper 3 because of the some reasons which they were not made familiar to us, but it's okay. Paper 3 is one of the simplest papers among these 3 papers, paper 1 and paper 2, because it just measures the mental ability of a student. It doesn't need a calculator. It's just an exam which is so smooth, so simple. Just needs your understanding and ability to think quickly. All right, here we go to the next concept. The next concept is finding the lowest common multiple. Oh, now you already know the multiples of a number, how to generate multiples of a number. Now we are going to find the lowest common multiple of each of these numbers you can see here. We are looking for the lowest common multiple of a pair of numbers you can see. Now, we have plenty of methods of figuring out the lowest common multiple of pairs of numbers. You can have 2 numbers and they ask you to find the lowest common multiple, or you can have 3 numbers and they're asking you to figure out the lowest common multiple. So we have plenty of methods, but the methods which I'm going to use here, let me check. Should I go for 3 methods? Let me check how far we'll go. Let me start with method 1. Let me start with method 1. Okay, method 1. The way how it sounds, the question is find the lowest common multiple. The lowest common multiple of each of these numbers. Okay. So method 1 is I take this number, the first number here, and I list the multiples of that number. So here I list the multiples of 6. Okay. Once that is done, then I go to the second number. I list the multiples of this number 8. So once that is done, then I extract. I have to pick up those multiples which are found in both cases. So that is the way forward. And then from those common multiples, I'm going to select which common multiple is the lowest of them. And that will be our final answer for the lowest common multiple, which we call it LCM of 2 numbers or 3 numbers or 4 numbers and so on and so on. But for the case of demonstration, I'm going to use only a pair of numbers. That means 2 numbers. Okay. So here we go. Method 1, multiples of 6. Now you know how to. I explained to you in the previous discussion how to figure out the multiples of a number. Okay, so I'm going to use the concept of addition, that the first multiple of the number 6 is the number itself. And then I add 6 to 6, I'm getting 12. Okay, then next, keep adding, I'm getting, 6 plus 12, I'm getting 18. Next number will be 24. Next number will be, add 6 over here, will be 30. Next multiple will be 36. Next multiple will be, guess what, add 6 over here will be 42. Add 6 on the 42 will be 48. Add 6 over here will be 54. The next multiple of 6 will be 60, and so on and so on. You know, multiples of a number, they go to infinity. That means we can't list them all. Okay, so 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, maybe carry on forward. We got, 60 plus 6, we get 66. You can say, and so on and so forth. Okay, because multiples of a number, They usually go to infinity. Okay, so once multiples of 6 are done, then you go to multiples of the next number, that is 8. Okay, multiples of 8. See that? Cool, yeah? Good. So you do, let's extend the margin over here. Okay. Here we go. Okay, multiples of 6 are done. Multiples of 8, using the concept of addition to figure out the multiples of 8. So you start with 8 itself, then add 8 to 8 will give you 16. Add 8 here will be 24. Add 8 here, let me check, plus 8, 16 plus 8, 24 plus 8 here will be 32. Plus 8 here will be 40. Plus 8 here will be 48. Plus 8 here will be 56. You can just check for me. 56 plus 8 will be 64. Plus 8 here will be, okay, what is that? 64 plus 8 will be 72. Maybe you can stop here for sake of demonstration. Now, we already know the multiples of every single number involved over here. So now we are going to put a ring around multiples which are common. Okay? Common multiples. See that? Common multiples. Now, how do we find multiples which are common? Common multiples represent a set of multiples which are found in a list of multiples of 6. At the same time, they are available in a list of multiples of 8. Those are what we call common multiples. Okay, let me put a ring around those common multiples. We have 6 here, we don't see a 6 over here. We have 12. How about here? We don't have 12. 18, we don't have 18. Oh, we have 24 here in the multiples of 6, and also we have 24 here in the multiples of 8. So put a ring that is making up the first common multiple. So 24 is our first common multiple. Keep going. We have 30 over here. Do you have 30 here? No, we don't have 30. 36. Do we have 36 in here? No. 42. Do we have 42 in multiples of 8? Nope. 48 in multiples of 6. Yes. We have 48 in multiples of 6. And we have 48 in multiples of 6. So 48 is one of the common multiples. 48 is one of the common multiples. Okay. Let us figure out if we can get few of more common multiples. We are here in 48, 54. In multiples of 6, we have multiples of 6. No. In multiples of 6, we have 54. But in multiples of 8, we don't have 54. We have 56. Carry on. We have 60 in multiples of 6. Do we have 6 over here? Nope. Nope. Cool. Now, I have got two common multiples. Now, I can choose to stop here. The reason being, I'm looking for the lowest. I'm looking for the lowest common multiple. Okay? I'm looking for the lowest common multiple. And I got two of them. So from that list of two common multiples, I can choose which common multiple is the lowest of all. So I have advantage. I can get two common multiples and select the lowest common multiple, because that is the question. The question is demanding for the lowest common multiple. Okay? Cool, yeah? Good. Now these are common multiples. These are common multiples. We have 24, 48, and so on. Now let me ring which one is the smallest of all. Here we go. 24 will be the lowest common multiple. The lowest common multiple, call it LCM of two numbers. These two numbers were 6 and 8. So the lowest common multiple of 6 and 8 has been found to be 24. See that? Cool, yeah? Good. So, so far so good. We have got the lowest common multiple of the first pair of numbers, 6 and 8. So the lowest common multiple of 6 and 8 is 24. That is by using the method of listing multiples over every single number. Now we have another method. Now because of time, I'm not going to use all these methods in the next questions. I'll be choosing the easy method. Okay, method 2. This method 1 is listing multiples. See that? Method 1 is listing multiples. See that? Listing multiples of every single number. Now method 2 is finding the LCM by prime factorization. Okay, see that? By prime factorization. Now how is this done? It's very easy. You put the numbers over here. The numbers are 6 and 8. Keep a border between those two numbers. Okay, let me use clear border. Here we go. Put the border. Put the borders. Put the borders like so. Go like so. See that? Let me continue. Prime factorization. So what does prime mean? The numbers we put here should all be prime numbers. I will explain you what does prime number mean, but I already introduced to you that a prime number is any number except 1. So we are going to use all prime numbers over here except 1, because we say a prime number is any number except 1, but such a number should be divisible by 1, and also it should be divisible by itself. So we say a prime number is any number which has only 2 factors. Okay, so the smallest possible prime number, the smallest possible prime number is 2. Then we check 6 divided by 2 is 3, 8 divided by 2, this is 4. See that? Then you still have a number among 3 and 4 which is divisible by 2. Carry on. 3 divided by 2 is not possible. Copy and paste 3 over here. 4 divided by 2 is 2. See that? We still have a number divided by 2. 3 divided by 2 is not possible. Copy and paste 3 over here. 2 divided by 2 is 1. See that? Cool, yeah? Good. Now, we don't see any possibility of putting a 2 here, because 3 is not divisible by 2. So we go for 3 itself. So 3 divided by 3 is 1. 1 divided by 3 gives you a decimal. Copy and paste 1. So that is marking the end of prime factorization. Now, remember our question is to find the LCM. So now, how do we find the LCM of 6 and 8? So what we do, we simply multiply those results for our LCM. See that? So our LCM, or the lowest common multiple of 6 and 8 will be equal to I multiply all these numbers. So let me pick up the highlighter and show you the numbers which I'm talking about. Do that. These are the numbers which we have to multiply in order for us to get what we call the LCM of those two numbers, 6 and 8. So the LCM will be 2 times 2 times 2 times 3. Work out that this will be 2 times 2 is 4, 4 times 2 is 8, 8 times 3 will be 24. Cool, yeah? So you see that? And remember what we got? We got 24 here by using the listing method. See that? Got this one. See that? So our answer is very correct. And this is method 2, which we call it prime factorization. Good. Now, I will go for the last method, but I'm not saying that this is the only, I'm not saying that these are only 3 methods of finding LCM. There are so many techniques of working out the LCM of 2 numbers, the LCM of 3 numbers, the LCM of 4 numbers. But if you still have a problem on how to find LCM of numbers, you can still try to private message me, and that means just send me a message privately, then I'll come back to you and I will explain you on how to find the LCM of 2 numbers, 3 numbers, and so on accordingly. So I also have my Skype team where my students contact me for more help in maths. So I will go to that and I will explain everything on how do I do lessons through my Skype team. But for now, let us carry on. Okay, so we got the LCM by the method of prime factorization. Now, let us go to the last method, which is my favorite, and this will be method 3. Now, method 3 is using a factor tree. See that? Using a factor tree. Now, you may be wondering, how does a factor tree look like? I will explain all those. Don't worry. Stay tuned and see how things are happening. Okay, we go back to the question. The question is find the lowest common multiple of each pair of numbers. We have 6 and 8. That is our first pair. So what do? We do a factor tree. How does this factor tree look like? The numbers are 6 and 8. The numbers are 6 and 8. Let me start with a factor tree for a number 6. So how does a factor tree look like? We just consider the divisibility. Okay, factor tree. And this factor tree takes use of all numbers which are divisible by 6. Okay, the smallest number, okay, is 1. We know, because a factor tree does not necessarily to take use of prime numbers. Okay, but if we start with 1, it's like we are repeating, because 6 divided by 1 is a number itself. So you better move to 2, because 6 divided by 2 makes different than just saying 6 divided by 1, because 6 divided by 1, you go back to the number itself, and that is 6. So just ignore 1, go to 2. 6 divided by 2 is 3. Okay, so 2 is a prime number, 3 is also a prime number. That means it cannot be further broken down into factors. So we stop there. Now, how do we record this? We just say 6 equals to 2 times 3. Cool, yeah? Correct. How about 8? 8, you start with 2. Okay, 8 divided by 2 is 4. 2 is a prime number. I mean, 2 is a prime number, cannot be further broken down, but 4 can be further broken down by 2 here. 4 divided by 2 is 2. So what does it mean? 8 equals to 2 times 2 times 2. 2 times 2 times 2. 6 is 2 times 3. This is what we call a factor tree. Cool, yeah? Good. Now, how do we use this to work out the lowest common multiple of those two numbers, which is I mean the lowest common multiple of 6 and 8. So here we go. For the LCM, listen carefully. For the LCM from this concept, for the LCM, we first identify the numbers. The numbers which are common. What does it mean? We have 2 over here, we have 2 over here, and we have 2 in 8. So we cancel 2 and 2 because these are common numbers. And you record it here. Correct. The next, you again check in 6, we have 3. But in 8, we don't have a 3. So in that case, 3 is not common. So you put a ring around that and you record over here. Correct? Good. So we are done with all numbers in 6. Then we go to the numbers in 8. We can see a 2 in 8, but we have a 2 in 6, but it was already cancelled. You see? So we have a 2 in 8, but we don't have any other 2 in 6. So in that case, this 2 is not common. And you record it over here. Again, we have another 2 in 8, but we don't have any other 2 in 6. So that means this 2 is not common. We put a ring around that, and we record it. We just record it over here. Now, we are good to go for the LCM of these 6 and 8. The LCM will be multiply all this. So this will be 2 times 3, that is 6. 6 times 2, that is 12. 12 times 2 is 24. See that? So LCM of 6 and 8, we are still getting the same answer, that is 24. See? Sorry, I have made my presentation on LCM because this is a place where so many students get confused. Okay, but I'll be, for the next other questions, I'll be going for one method, and that will be as simple as that. Okay, now you can pause the video, and try B and C. Now, students usually ask, should we use all these 3 methods to answer one question? No, the answer is no, because I have done all these 3 methods just for demonstration purpose, and then you choose which method you are comfortable with. See that? If you are comfortable with method 1, which is all about listing multiples, then you are good to go for that. If you are comfortable with prime factorization, then you are comfortable to go for prime factorization. If you are comfortable with method 3, which is using a factor tree, then you are comfortable to go for that. Otherwise, doing the next other questions using all the 3 methods will be wastage of our time. So without wasting our time, without further ado, let us do question B. But you can pause the video and try B and C. Good. All right. Now let us see how do we do this question. I will go for method 2, prime factorization. Yes. So I'll be going for prime factorization. See that? I'll be going for prime factorization. I hope you remember the method. Prime factorization is one of the easiest methods to work out the LCM of two numbers. So how does it look like? You can revise it. Over here. This is what we call prime factorization. Cool. Okay, without further ado, let us go for it. We have 9 and 12. The numbers are 9 and 12. If you have got three numbers, for example, finding the LCM of 9, 12, and say 36. So the next other number will be recorded like so. So you put borders, you see, put borders over here, and then you proceed. But since we have two numbers, let us go for two numbers. Okay, like that. This should be out, and then we're good to go for that. Make that look neat. Push it here, and push this over here. Then we are good to go. We have 9. This is 12. Put another margin over here. So the smallest number we start with is 2, if 2 is divisible by all these numbers over here. But 9 is not divisible by 2, but 12 is divisible by 2. So because of that, we have to start with 2, because 12 is divisible by 2. Okay, 9 divided by 2 is not possible. Gives you a remainder, so copy and paste 9. But 12 divided by 2 is 6. We still have got one of the numbers divisible by 2, that is 6. So we go for 2. 9 divided by 2 is gives you a remainder, so copy and paste 9. 6 divided by 2 is 3. Correct. Then we don't have any other number that is divisible by 2. So we go to 3, because 9 is divisible by 3, and also 3 is divisible by 3. So we have advantage that it is divisible by all these numbers over here. So 9 divided by 3 is 3. 3 divided by 3 is 1. Okay, go to next, 33. 3 divided by 3 is 1. 1 divided by 3 gives you a decimal. So copy and paste 1, and then you stop over there. Okay, let me extend this margin. Cool. Okay. Good. Now we are going to the conclusion. What did the LCM of 9 and 12? What did I say? For finding the LCM of those numbers, what we basically do is multiply. You multiply these numbers over here. Correct. Now, listen. How do we multiply those numbers? The work is easy. Simply take out that 2 times 2 times 3 times 3. So LCM will be 2 times 2 times 3 times 3. Cool, yeah? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So you can check that using a calculator and come back to me. So this is 4. That will be 36. So LCM of 9 and 12, the LCM is 36. You can pause the video and try C, but if you are still facing difficulties, then you are good to go with the video and then learn more. Correct. Now let me go to the last question. This is finding the LCM of 4 and 14. Now this time I'm going to use factor tree. I'm going to use factor tree over here. Okay, I start with the first number. This is 4. This is divisible by 2. And this is 2 itself. Oh wow, just small factor tree, very short one. Okay, 14 is 2 times 7. Okay, it's like just small numbers. Okay, now LCM will be as follows. Start mentioning or start writing 4 as a product of its primes. This will be 2 times 2. Go to 14. This will be 2 times 7. Now once you get that done, then you find what we call LCM. Now, LCM, like as I said earlier, we start focusing on common factors. You see that we have a 2 over here and we have 2 over here. You cancel that, those are common factors. They are found in 4, they are found also in 14. So cancel them and you record that over here, then times. Now, we can see a 2 over here, we can see a 2 over here, but we don't see any other 2 as one of the factors of 14. Why? Because this 2 over here was cancelled with this 2 over here, so it's no longer counted. Okay, so this 2 in 4, this 2 here in the list of factors of 2, factors of 4, this 2 is not common. Why? Because we don't see any other 2 in 14. Okay, so you include it over here. Alright, so we don't have any other number remaining here. We go for numbers in here. We have 7. 7 is not common because we don't have 7 in 4. So put it over here. So LCM will be 2 times 2, that is 4. 4 times 7, that will be 28. Okay? I hope if you pause the video, I hope you got the same answer. And that is how we do the LCM. Cool, yeah? All right. Now, let me check. 2 times 2 times 7. Yeah, that's 28. Okay, so on this page, I'm done. Then I move on to the next page. Okay, the next page is, all right, find the highest common factor. Oh, good. Find the highest common factor of 24 and 32. Cool, yeah? Good. Finding the highest common factor, in short we call it HCF. Also, this has three quick methods. See? Three quick methods. I'm going to show them over here for the purpose of demonstration. So let me go for method 1. I will tell you what is that. Then I'll go for method 2. I'll tell you what is that. Then I'll go to method 3. Maybe I can go even for method 4, but just these 3 methods are more than enough. So method 1 is, since the question is looking for the highest common factor of these 2 numbers, 24 and 32, what you simply do is to list the factors of every single number there. Remember? Yes, I taught you how to find the factors, how to list the factors of a number. I told you that the factor of every single number is 1. Okay, so here the method number 1 is by listing factors of every single number. Okay, let me start with factors of 24. Okay, let me start with factors of 24. Okay, let me prepare a place where we will be doing some rough work. Okay, we'll be doing our rough work over here, okay, in that region. Cool. All right, so let's try to list the factors of 24. Okay, 24. Okay, factors of 24. I said 1 is a factor of every number. Okay, so 1 is the factor. Now to get the next factor, you do 24 divided by 1 is 24 itself. Okay, then you go to 2 It's like you are counting from 1. It's like you are counting from 1 to the number itself, 24. So you count 1, 2, 3, 4, 5, 6, 7 until 24, and then you select which numbers in the list are divisible by 24. Okay, so 24 divided by 1 is 24. So 24 is one of the factors of 24. Okay, go to 2, because in counting after 1 you go to 2. Okay, 24 divided by 2, yes. What is 24 divided by 2? That is 12. So 12 is one of the factors. In counting after 2, go to 3. Check if 24 is divided by 3. The answer is yes. It's 8. Go to 4. 24 divided by 4, is that divisible? Yes, that is divisible. That is 6. See that? Go to 5. 24 divided by 5 is not possible. Gives you a remainder. 24 divided by 6. Yep. 24 divided by 6 gives you 4, but we already recorded 6. You see that? So once the numbers are getting repeated, you stop. You see? So 24 after 4, in counting 1, 2, 3, 4 comes 5. 24 divided by 5 is not possible, gives you a remainder. You go to 6. Now once you go to 6, 6 is already recorded here. So it's like you are starting repetitions. So by the time you start repetitions, you stop. That mark at the end of the factors. Okay, let me keep the factors of 24 over here. Factors of 24. Factors of 24 are 1, 2, 3, 4, 6, 8, 8, then we went to 12, and 24. You see that? Cool, yeah? Good. So we are done with factors of 24. Let us delete all this and we go for the factors of 32. Factors of 32. Okay. 1 is a factor of every number. 32 divided by 1 is 32. Record it over there. Go to 2. 32 divided by 2 is also possible. We get 16, so 16 is one of the factors. Go to 3. 32 divided by 3 is not possible. Go to 4. 32 divided by 4. Pull out the calculator, do 32 divided by 4. See that we're getting 8. So 8 is a whole number, has no remainder. The remainder is 0. So 32 divided by 4 is 8. Okay? Go to 5. 32 divided by 5 leaves you a remainder, so ignore 5. Go to 6. 32 divided by 6 is not possible, gives you a remainder. Go to 7. 32 divided by 7 is also not possible. Go to 8. Now 8 is already recorded here. So repetitions, once you start seeing repetitions in getting a list of factors, then what you simply do is you stop. And then you get a list here of factors of 32. The factors are, we got 1 over here, we got 2, we got 4, we got 8, we got 16, we got 32. See that? 1, 2, 4, 8, 16, 32. Cool, yeah? Good. We are done. Now, the question here says, the question says, find the highest common factor. What does it mean? We need to get common factors. We need to get common factors because the question is asking for the highest common factor. So we need to have common factors. Okay? Now there's a question over here. So what I'm going to do is we have another question who's talking about mere. Okay, now what I'm going to do for now, I will have to, for now, let me block this question of mere. Give me a second. Okay, lock that in place. Mere. Okay, let me block that question for now to avoid confusion. Here we go. block that question of Mia for now. Okay, yes, here we go. Block this question. Yep. Cool, yeah, good. And extend this one over here. Extend this margin over here. Okay, good. So delete that, put a new margin. Yep, yes, so cool. Method 1 is asking for the listing factors, the highest common factor of 24. Okay, now let us continue. Sorry for the delay, but this is part of the learning. Common factors. Okay, common factors. Let us pull out the common factor. Okay, common factors. Let me try to link them. Oh, let me use a highlighter so that you can see the common factors. Okay, common factors. You can see one over here. We have one over here. We can see a 2. We can see a 2. We can see a 3 here, but we don't have a 3, so we skip 3. You can see a 4. See that 4 is common. 6, we don't have 6 in there. We have 8. We have 8 over here. Then 12, we have 12 here, but we don't have 12 here. How about 24? We have 24 over here, but we don't have 24. See that? Cool, yeah? So, let me pick up the pen and continue. Okay, so factors of 24 stops here. Factors of 32 stops here. The common factors are, we got 1, we got 2, we got 4, we got 8. Do we have another common? No, we don't have any other common factor. Now, remember the question? The question is, find the highest common factor. Oh, the highest common factor. The highest common factor. The highest common factor. You can pause a video and figure out the highest common factor from here. Okay? So 1, 2, 4, 8, the highest common factor of these two numbers, 24 and 32, is the highest common factor is 8. See that? Cool, yeah? Good. I hope you are enjoying the lesson. So let me go to method 2. Like as I said for lowest common multiple, that you don't have to use all these methods. You choose one method which you're comfortable with, and then you do it. Save time in the exam. Choose one method which is easy to you, and then you are good to go for. You'll be able to save the time, save space as well, and save resources. Cool, yeah? Method 2 is prime factorization. How do we use prime factorization to work out the highest common factor? Correct. So you put, I already introduced to you how to do prime factorization, so here we do it quickly. We have 24, we have 32. Do that. Prime factorization starts with the smallest possible. Prime number, that is 2. 24 divided by 2 is 12. 32 divided by 2 is 16. 16. And then you still go for 2. 12 divided by 2 is 6. 16 divided by 2 is 8. Also, that is still divisible. 6 divided by 2 is not divisible. Gives you a remainder. Copy and paste 6. 8 divided by 2 is 4. That is possible. Okay, we still have some numbers divisible by 2. Oh, sorry for this. 6 is divisible by 2. Sorry for that. Okay, here we go. Alright. So let us repeat afresh. 6 divided by 2 is 3. 8 divided by 2 is 4. Correct? Good. So that's part of learning. Making mistakes is part of learning, which as teachers we accept that. So making mistakes is part of learning. Good. Let us continue. 6 divided by 2 is 3. 8 divided by 2 is 4. Now we still have 4. 4 is divisible by 2. But when it comes to 3, 3 divided by 2 gives you a remainder. Copy and paste 3. Why? Because 3 divided by 2 gives you a remainder. 4 divided by 2 is 2. Okay? We still see that 2 is divisible by 2. So go for that. 3 divided by 2 is giving you a remainder. Copy and paste 3. But 2 divided by 2 is 1. Stop there. So for dividing by 2, this is the end. Then you go for 3. See that? 3 is divisible by 3. So 3 divided by 3 is 1. But 1 divided by 3 gives you a remainder. So you copy and paste 1 over there. Then, remember the question? Okay, sorry, my daughter came to talk to me. She doesn't know it's my small daughter, it's my small child. So she kind of came to see me, what I'm doing, starting talking to me. Then I just stopped her immediately because she's still young. Sorry for that. Here we go. Now, we are talking about, we are looking for the highest common factor. The highest common factor of 24 and 32. Now, from here, let me highlight. From here, we are going to choose from here. See that? We are going to select which number or which factor was divisible by both 24 and 32. So you find that 2 was divisible by all these numbers here. 24 divided by 2, we got 12. 32 divided by 2, we got 16. Also, this 2 was divisible by all these numbers. So 2 will be part of our calculations for highest common factor. How about this 2? 6 divided by 2 was possible, 8 divided by 2, so this number. Okay, how about this one, 2? See this 2 here wasn't divisible by 3. Okay, so this 2 here will not be used. So this 2, cross that. Okay, how about this 2? Also this, cross that. How about 3? This 3 was divisible by 3. But how about 1 divided by 3? It was not possible. 1 divided by 3 gives you a remainder, gives you a decimal. So this 3 will not be used for calculations of HCF. So what does it mean? HCF will be equal to, you multiply these numbers which we ticked. Okay, you multiply 2 times 2 times 2. What is the answer? 2 times 2 times 2? 2 times 2 times 2 is 8. Now when we compare with our previous answer, we are getting that our previous answer was correct. So hence method 2 is done. Okay, let us go for method 3. Now method 3 is, guess what? We did listing, we did prime factorization. Method 3 will be a factor tree. Factor tree. See that? Factor tree. Now, how do you use a factor tree? We take a number 24, break down that by 2. This is 12. By 2, that is 6. 2 times by 2, that is 2 times 3. See that? Okay, how about 24? I'm sorry, 24 is done. How about 32? 32, you do the same thing. 2 divided by 32 divided by 2 is 16. 16 divided by 2 is still possible. Is you 8. 8 divided by 2 is 4. Okay. Then still this can be broken down. This is 2. Okay, now how do we do that? Let me make let me cut that, paste it over here. Okay, extend that. Good. And this will be the last method, factor tree. Okay, so this is 24, which can be written as a product of its primes. This is 2 times 2 times 2 times 3. So 2 times 2 times 2 times 3. 2, 2, 2, 2, 2, 2, 3. Then for 32, you do 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Okay. Now remember, our discussion is for the highest common factor. Highest common factor. So over here is how it sounds. We are looking for the highest common factor. Common. Which factor is common over here? So 2, 2 is common. Record it over here. 2, 2 is common. Record it over here. 2, 2 is common. Record it over here. How about 3? We have 3 in 24. We don't have a 3 in 32. How about this 2? This 2 is common, but we don't have any other 2 remaining. How about this 2? We have 2 over here, but we don't have any 2 remaining in 24. So these 2 2's and 1 3 will not be recorded for highest common factor. It's a little bit different with the LCM. So HCF will be equal to 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. See that? So all the methods, we are getting the same answers. See that? So I hope this helps. This is the end of my presentation for today, and we're going to continue with the other remaining questions of the worksheet. So thank you very much, and this is the end of my presentation. Good. My name is Mr. Zabron Ernest Ofoli from Dar es Salaam, Tanzania. I'm a teacher in maths. I also help students who learn online. How does this online teaching take place? Normally, this online teaching is one-to-one session, and that is done through Skype. Okay, so if you have your Skype ID, you can contact me from the information that I'm going to give you underneath over here. My Skype ID is Zabron.Ernest. See that? So Skype, this is my Skype ID, Zabron.Ernest. What do you have to do? You simply add me in your Skype contacts and then upload the questions which you would like to discuss with me. You can upload to my Skype ID, and then you just give me a couple of, some few minutes. I prepare a lesson plan for you, and then we are good to start. Okay, so what definitely I do, once I get your questions which you want to discuss with me, what I do, I prepare a lesson plan. I look at the questions themselves. I prepare a plan, and then what I do, once I have your questions on my screen over here, is how you can see my screen. What I do, I call you back through your Skype ID. Once I call you, and once you pick up my call, once you respond to my call, and then I share my screen. I share my screen with you from the comfort of your home. That means you don't have to come to my home, or I don't have to come to where you stay. this is done online. So you just call me back, or I can call once I get your Skype ID. I call you back, and once I have got the questions in place, the questions which you would like to discuss with me, once I've got those questions in place, what I do, I call you through my Skype, and then once you respond to my call, then I share my screen. That means you'll be able to see my screen, and the questions which you sent me will be displayed on my screen, and then we start learning. You learn from the comfort of your home. I also teach you from the comfort of my home. So nobody is losing anything over here. I stay in my house, you stay in your house. Through my Skype team, we talk to each other. You can even see me. You can see everything over here on the screen, and that is how it takes place. Believe me, learning maths is fun. Learning maths is fun, and you will really enjoy. So for now, bye bye, and I will join you later for the remaining other questions. All right, bye. See you then.